Okay, so let us start. Hi everyone, I am Om, and today I welcome you all to week 9 live session of NPTEL Digital System Design. Just give me a moment. Okay, so let us start. So this is our last live session, and in today's session we will be talking about FPGA VLSI design flow using HDL, Introduction to Behavior, Logic and Physical Synthesis. So let us see question 1. What is the purpose of bit file configuration for FPGAs? Option A, it changes the FPGA into memory. B, with uh, configuration, FPGA dynamically changes from one circuit to another. C, with configuration, FPGA works like a specific circuit. Configuration is used for functional verification. So if you remember from the lectures, bit file is generated at the last step after logic synthesis and as well as after the synthesis. So after synthesis, the bit file is generated, which is to be sent directly to the FPGA so that it could simulate the circuit that uh, to implement the circuit that we have tried to create. So the correct answer is with configuration, FPGA works like a specific circuit. Next question. Which of the following technologies is preferred when we need chip in larger quantity and at low cost of individual product? Option A is ASIC, application specific circuit design. Option B is FPGA, field programmable gate array. So if you see what is an ASIC, ASIC is a custom design that has to be fabricated for any specific purpose. There is FPGA. FPGA is a general purpose array of logic and interconnects which can be fused into any circuit that we want. So, but it is highly inefficient and it is good only when we want to do when we only want to do some study or we want very less number of circuits. But when we need circuit in a very large quantities, like any specific circuit in a mobile phone, so millions of mobile phones are made together. So uh, that's a large scale implementation of any circuit. So for that, it is better to use ASICs. So the answer is ASIC. So when we need in a larger quantity and the low cost of individual product, then we do ASIC. Whereas when we need smaller quantity we do FPGA. Okay, so the next question. How many input line mux is required to realize 7 input OR gate? So we have to implement a 7 input OR gate using a mux. So how many input lines should be there in a mux? So if you remember from the lecture, to the power n input multiplexer can be used to design any logic gate of n plus 1 inputs. So this means that 2 to the power n mux n plus 1 input logic. So our n plus 1 is 7. So n is 6. So 2 to the power n is 2 to the power 6, which is 64. Right? So you need 64 input mux. Now the next question is, what is the size of the configuration file to realize this given circuit in lookup table? So again, we have this circuit where this mux, we have 3 variables, right? S0, S1 and C. So for a 3 variable, uh, it is for 3 inputs, we need 2 to the power n cross 1 memory for n input. So this is 3 variables. We need 2 to the power 3 cross 1, which is 8 cross 1. Okay. Next one is, how many input lines are required for the LUT in the given block diagram, the circuit given in question 4 to be implemented. So if this circuit has to be implemented, how many input lines do we need? So this LUT, we know we need 8 cross 1 memory, right? And to access those 8 memory blocks, we need 3 input lines, right? So we need 3. Next question. A channel is used to connect two CLBs in FPGAs. What is CLB? Combinational logic block. So yes, this is true. A channel is used to connect two CLBs in FPGA. Channel can be any interconnect. Next question. A circuit designed and to be implemented on an FPGA board. Inputs of the circuit are taken from switches present on the board and outputs are shown on LEDs present on the board. How input outputs in Verilog will map to the switches and LEDs present on the board. So if you remember the video, we had LEDs like U19, U13 at different pins of the actual chip. So how did we define them? Using constraint file. So we use the constraint file to define what pins of the FPGA are to be used by the specific LEDs. So we need constraint file. Which of the following blocks is not part of programmable internet? Option A, connection box. Option B, switch box. Option C, transmission gate. Option D, configurable logic block. So as you know, all these three can be used in interconnects. But the CLB is the logic block. This is not an interconnect. So this is CLB is not a part of the interconnect. Okay, next question. Okay, next question is how many slices are there in one CLV of xylenes? So if you remember, there are four slices in one combinational logic block of xylenes. Next part of the question, how many LUT are there in four CLBs of xylenes? So if you remember, xylenes has four CLB and each CLB has four LUT each. So in total, we have 4 into 4, 16 LUT. What would be the input to the physical design stage in FPGA design flow? Okay, so if you remember the whole flow, we start with our SDL specification, then we go to the design synthesis, and then output of the design synthesis and the FPGA part number is sent to the physical design stage. So the answer is option C. Okay, so next one, what would be the input to the design synthesis stage in FPGA design flow? So as we discussed, we start with the Verilog code, right, to the design synthesis. Then the output of the design synthesis is sent to physical design. So correct answer is SDL specification. What is the correct order of design processes involved in FPGA design flow? So as discussed, we start with a simulation, simulation. This is like our Verilog. Then we do a design synthesis. Then the design synthesis output is sent to the physical design. Physical design later then generates a bit stream, which we send to FPGA. The combinatorial optimization is included in which phase of design system digital system design? A. Verification. B. Logic synthesis. C. Physical synthesis. D. Fabrication. So, if you remember the video, in logic synthesis, the logic optimization, we do the combinational optimization. First, we define what the circuit what we want to do with the circuit in the Verilog code. Then we do it the optimization. As we have seen in the previous few weeks, the state machine optimization is an example. So this comes in logic synthesis. So next question is the exact wire length or wire delay is known after which stage of the design flow out of given options. Algorithmic level design, register transfer level, floor plan level, transfer function level, placement level, none of the above. So when we do the floor plan, we know the exactly where our which block will be placed where. So then we can know the exact wire length and or the wire delay. So answer is floor plan level. Hi Nishant. So this assignment was whole theoretical. So these are all the questions I had. So you joined in, maybe I can quickly go through the starting questions once again since we have finished early. So this is a very simple assignment and totally theoretical. So let us review the questions since you didn't join earlier. Okay. What is the purpose of bit file configuration of FPGAs? So bit file configuration is generated at the end of the physical design, which is to be sent to the FPGA board, the hardware uh, FPGA. You have to send the bit file to the FPGA so that it can uh, configure itself and work and the LEDs may glow or whatever you have designed it to do. So bit file is generated at the last stage of the simulation so that you can send it to FPGA. So this is used to configure the FPGA to work like a specific circuit. Which of the following technologies are preferred when we need chip in larger quantity and low cost of individual product? So as you know, ASIC is application specific circuit. So it is costly to fabricate, but if we need in a large quantity, let's say millions or billions, So, like example, your mobile phone. So, a chip that is going into mobile phone, maybe a Snapdragon chip or some other chip, they are like millions of same mobile phones are made together. So, so to get to so when the manufacturing is done in large quantity, to lower the cost of individual product, we do ASIC design. Whereas FPGA is for a very small number of number of uh, we do not need a large number of chips. So FPGA is a very general purpose generic board where just for a one or two cases we want to make some circuit, we cannot go for ASIC design. Then we implement it using FPGA. How many input line mux is required to realize 7 input OR gate? So if you remember the video, 2 to the power n input mux can be used to design any logic gate of n plus 1 inputs. So here 2 to the power n mux can design n plus 1 logic input logic. So n plus 1 here is 7, n is 6, 2 to the power 6 is 64. So you need 64 input mux. What is the size of the configuration file to realize this the given circuit in LUT? So here we have three variables, C, S0 and S1. So LUT should have 2 to the power 3 memory units, right? That is 8 cross 1 memory. So answer is 8 cross 1. Next question, how many input lines are required in LUT in the given block diagram of the circuit? So as we saw, we need 8 cross 1 memory. So to access these 8 addresses, we need 3 input lines in the LUT. Since 2 to the power 3 is 8. So to access these 3 inputs, to access these 8 memory units, we need 3 inputs in the LUT. A channel is used to connect two CLBs in an FPGA. So CLB is combinational logic block. So channel is any interconnect. So this is true. Sorry, my internet got disconnected. Okay, so we had discussed this question. A channel is used to connect two CLBs in an FPGA. This is true. A circuit is designed and to be implemented on an FPGA board. Inputs for this circuit are taken from switches present on the board, and outputs are shown on LEDs present on the board. How inputs and outputs in Verilog will map to switches and LEDs present on the board. So if you remember the video, so there were LEDs whose pins were connected to the actual pins of the chip, right? U19, U13, and something like that. So we defined everything, all this in the constraint file, which was fed as an input to the Vivado. So a constraint file is required, which needs which is needed to be given as input to the FPGA software, where this constraint file just defines at which pin what do we have. Which of the following blocks is not part of programmable interconnect? Connection block, box, switch box, transmission gate. So these all three are interconnects. Configured logic block is the actual logic block which needs to be connected using this programmable interconnect. So CLB is not a part of programmable interconnect. How many slices are there in one CLB of Xilinx? So there are 4 slices. How many LUT are in 4 CLB blocks of Xilinx? So in Xilinx, you have in the FPGA board, you have 4 CLB, and each CLB has 4 LUTs. So total in 4 CLBs, you have 4 into 4, 16 LUTs. What would be the input to the physical design stage in a FPGA design flow? So as discussed multiple times, we first do the simulation or the SDL, like the Verilog. Then you do design synthesis. Then its output is sent to physical design. So the output of the design synthesis and the FPGA part number sent to the physical design stage. Similar question. What will input to the design synthesis stage? That is the HDL specification, the Verilog code. Correct order of design process involved in FPGA design flow. First we do simulation or the HDL, then design synthesis, then physical design and bit stream generation, which is finally fed to the FPGA hardware. Combinatorial optimization is included in which phase of digital system design? This is in logic synthesis, which is can be verified from this from the last video. I said wire length or wire delay is known after which stage of design flow, 4 to 10 levels. Okay, so this was all. Do you have any doubts, Nishant? Okay then. So uh, probably we are meeting for the last time. So all the best for your exams. If you get any doubts in between, you can email me. When is your exam? Saturday. Okay, it's not far. So okay, practice well. So mainly look at all the assignments as well as the questions that I have shared. So that should be enough to score well and pass in the exams. If you understand all the basics, you can do well in the exam easily. Okay then. Thank you for joining.